Hello students. In this video we are going to discuss conic sections or conics, which includes ellipse, circle, hyperbola and parabola. You need to understand these structures properly, so watch this one-shot video on conic sections till the end and subscribe to the channel. So what are conics? The curves like circles, ellipses, parabolas and hyperbolas are known as conic sections or more commonly conics because they can be obtained as intersections of a plane with a double-lapped right circular cone. Now what is this? Let us understand. Also the names parabola and hyperbola are given by Apollonius. Now let us understand. Let L be a fixed vertical line and M be another line intersecting it at a fixed point V and inclined at an angle alpha. Suppose we rotate this line M around the line L in such a way that alpha remains constant. You can see the first figure. Then the surface generated is a double-lapped right circular hollow cone, or you can say a simply cone extending indefinitely far in both the directions. In the second diagram you can see that if suppose M is rotated around L, a double-lapped cone type of structure is obtained. The point V is called the vertex, the line L is called the axis of the cone, and the rotating line M is called the generator of the cone. The vertex separates the cone into two parts called nads. So let us define the conic section. If we take the intersection of a plane with a cone, the section so obtained is called a conic section. Thus, conic sections are the curves obtained by intersecting a right circular cone by a plane. You can see in the diagram. Now, if we intersect the right circular cone with a plane, then we obtain different structures depending on the position of the intersecting plane with respect to the cone and by the angle made by it. Now, suppose if beta is the angle made by the intersecting plane with the vertical axis of the cone, then the intersection of the plane with the cone can take place either at the vertex of the cone or at any other part of the nap, either below or above the vertex of the cone. It is very clear that when a plane intersects the cone, then the intersection can take place either at the vertex or below or above the vertex. Now let us see how different shapes are made when the plane cuts the nap of the cone. Now first of all recall that alpha is the angle between L and M, the rotating line and the axis. And what was beta? Beta is the angle made by the intersecting plane with the vertical axis of the cone. So now first case is if beta is 90 degree, then when a plane cuts the nap of the cone other than the vertex, then the shape which is made is a circle. You can see in the first diagram. Suppose if beta is less than 90 degree, beta is between alpha and 90 degree, then the section is a ellipse. If beta and alpha are same, then the section cut out will be a parabola. Now, the last case is when suppose beta is less than alpha, beta is between 0 and alpha, then the plane cuts through both the naps of the cone and the curves of intersection will generate a hyperbola. Again, let us see the different shapes. In the first case, if suppose beta is 90 degree, then you know that a circle is generated. If beta is less than 90 degree, then ellipse is generated. In the second case, parabola is generated, and in the third case, when the plane cuts through both the naps, then hyperbolas are generated. In the cases till now, we had assumed that the plane cuts at any point other than the vertex. But suppose the plane cuts at the vertex of the cone, then we have the following cases. Suppose if beta is less than or equal to 90 degree, beta is between alpha and 90 degree, then the section is a point. If beta and alpha are same, then the section will be a straight line. It is called the degenerated case of parabola. When beta is between 0 and alpha, the section is a pair of intersecting straight lines and it is called the degenerate case of hyperbola. So now we are going to study each of the conics in detail. First one is circle. A circle is the set of all points in a plane that are equidistant from a fixed point in the plane. The fixed point is called the center of the circle and the distance from the center to a point on the circle is called the radius of the circle. Suppose in the given diagram, if C, which has coordinates h and k, is the center and r is the radius of the circle, let pxy be any point on the circle. Then by definition, you know the distance CP is equal to r, radius. But by distance formula, what will be r? It will be the difference, square root of difference of x coordinate square plus y coordinate square. That means x minus h whole square plus y minus k whole square. When you take the square root of that, you get r. So the general formula for r is r square is equal to x minus h whole square plus y minus k whole square. For example, the equation of a circle with center -2, 3 and radius 4 will be, here what is h? H is -2, k is 3 and the radius r is 4. So putting the values in the above equation, you get 16 is equal to x minus -2 means x plus 2 whole square plus y minus 3 square. When you simplify it, you get the equation of this circle as x square plus y square plus 4x minus 6y minus 3 equal to 0. Example 1. Find the center and radius of the circle whose equation is x square plus y square minus 8x plus 10y minus 12 equal to 0. First of all, we'll try to convert it in the standard form, which is r square is equal to x minus h whole square plus y minus k whole square. Now x square, the middle term, minus 8x is given, so we have to find the last term so that it becomes a whole square. Similarly, 10y is given, so we have to find the last term so that it becomes the whole square. So x square minus 8x plus 16 plus y square plus 10y plus 25. Since we are adding 25 plus 16 on the left hand side, we have to add on the right hand side. So ultimately the equation will be x minus 4 whole square plus y minus -5 whole square is equal to 53. So the center is 4 minus 5 and radius is root 53. Example 2. Find the equation of the circle passing through the points 4, 1 and 6, 5 and whose center is on the line 4x plus y is equal to 16. Again, comparing with the standard equation of circle r square is equal to x minus h whole square plus y minus k whole square, we put the points 4, 1 and 6, 5 in the above equation because these points are on the circle. So we put them in the equation of the circle. X is 4, then y is 1. Similarly, when x is 6, y is 5. So we get over here, and both the equations are equal to r square. So we equate both the equations. On solving it, we get the value h plus 2k is equal to 11. Let this be equation 1. Also, it is given that the center of the circle lies on the line 4x plus y equal to 16. So suppose hk is the center, then we put x is equal to h and y is equal to k. So we get the another equation 4h plus k equal to 60. And now we solve both the equations. Solving both the linear equations, we get the value of h as 3 and k is equal to 4. Hence the center of the circle is 3, 4. Now by the equation of circle, r square is equal to 4 minus h whole square plus 1 minus k whole square gives us r square is equal to 10 or r is equal to root 10. So the required equation of the circle is r square is equal to x minus h whole square plus y minus k whole square. In that we put h as 3, k as 4 and r square as 10. So the equation is x square plus y square minus 6x minus 8y plus 15 equal to 0. After circle, the next conic section is the parabola. A parabola is the set of all points in a plane that are equidistant from a fixed line and a fixed point which is not on the line in the plane. You can see in the diagram that over here the points P1, P2, P3 on the parabola are equidistant from the point F. This fixed point F is called the focus. Also, they are equidistant from the line L. This fixed line L is called the directrix. That means P1F is equal to P1B1. Same way P2F is equal to P2B2 and P3F is equal to P3B3. So the points on the parabola are equidistant from a fixed line and a fixed point. A line through the focus and perpendicular to the directrix is called the axis of the parabola. So you can just see that a line which is perpendicular to L forms the axis of the parabola. The point of intersection of the parabola with the axis is called the vertex of the parabola. So you have the focus, directrix, axis and vertex of the parabola. Now there are 4 standard forms of a parabola. Understand this properly. In the first case, suppose if the parabola is formed on the right side, that means facing towards the right side, then the equation of that parabola will be y square is equal to 4ax. Now in all our forms, we assume that the point O is the origin and the focus is at a distance a from the point O or the origin. So in the first case, you can see that f has coordinates a0, and so the coordinates on the directrix will be minus a0, because you know that O is a point on the parabola and it is equidistant from f and this side from the line. So when your focus is at a0, your parabola is facing towards the right side and the equation is y square is equal to 4ax. Below that, suppose if your parabola is facing towards the left side, the focus is on the left side of the origin. So let its coordinates be minus a0. In this case, the equation of the parabola will be y square is equal to minus 4ax. In the third case, suppose your parabola is facing upwards. That means over here the perpendicular line is the y-axis. So here the focus will be at the point 0a. Focus is at the distance of a units on the y-axis. O is the origin. So if your parabola is facing upwards, the equation of the parabola will be x square is equal to 4ay. Similarly, if the parabola is facing downwards, then the equation will be x square is equal to minus 4ay. And in this case, the focus will be at the point 0 minus a. Remember these 4 equations. Now some points to remember regarding the parabola. The equation to the parabola with vertex as the origin, focus at a0 and directrix x is equal to minus a is y square is equal to 4x, which we have just now seen. Now remember, a is greater than 0 always. X can assume any positive value or 0 but no negative value. And the curve extends indefinitely far into the first and fourth quadrants. So suppose if the equation is y square is equal to 4x, you can see that the curve extends in the first and fourth quadrant. The axis of the parabola in this case is the x-axis. Parabola is symmetric with respect to the axis. If the equation has a y square term, then the axis of symmetry is along the x-axis, and if the equation has x square term, then the axis of symmetry is along the y-axis. So now for the 4 cases, when the axis of symmetry is along the x-axis, the parabola opens to the right if the coefficient of x is positive. That means it is the equation y square is equal to 4ax. Suppose if it is left, if the coefficient of x is negative, that means equation is y square is equal to minus 4x. Now if the axis of symmetry is along the y-axis, then in that case the parabola opens upwards if the coefficient of y is positive and downwards if the coefficient of y is negative. We define one more term, the latus rectum of a parabola. Latus rectum of a parabola is a line segment which is perpendicular to the axis of the parabola through the focus and whose endpoints lie on the parabola. If you see the diagram, it is the parabola of the type y square is equal to 4ax. Over here, the line the line segment AB passes through the focus F and its endpoints E and B are on the parabola. So AB is the latus rectum of this parabola. Now we know that by definition, all the points, any point is there on the parabola, it will be equidistant. That means AF and AC. That point will be equidistant from the fixed point focus and from the line L. So AF will be equal to AC. This is by definition of parabola. But also we can see that AC is equal to FM. So AC is equal to FM, and that is equal to 2A. Why 2A? Because FM is 0 to F, origin to F and origin to M. So total distance is A plus A, 2A units. Therefore, since AC is equal to FM is equal to 2A, but AC is same as AF. So AF is also equal to 2A. So what will be the length of the lattice rectum? Lattice rectum is AB, which is AF plus FB. So the total length of the lattice rectum will be 2A plus 2A, which is equal to 4A. So remember, the length of the lattice rectum of a parabola will be 4A. Now this is very important. Just remember this chart for the parabola and you are done with the examples. There are 4 forms of parabola which are listed over here. For each of the form, the equation of the axis is given, equation of the directrix is given, the vertex is given. Vertex is we have taken by default as the origin. The focus is given and the length of the lattice rectum is given. You can note over here, obviously length of the lattice rectum in all the 4 cases will be 4A. So now if you remember this chart, you can solve any example for parabola. Example 3. Find the coordinates of the focus, axis of the parabola, the equation of the directrix and the length of the lattice rectum for the parabola y square is equal to minus 8x. So when we compare it with our standard form of parabola, which is y square is equal to minus 4ax, we get that minus 4a is minus 8 or a is 2. Remember, a will always be positive. And we also note that as the coefficient of x is negative, the parabola is open towards the left. So in this case, y square is equal to minus 4ax. What will be the coordinates of the focus? Minus a 0. That means minus 2, 0. Since the given equation has the y square, it is in the form of y square is equal to minus 4ax. We know that the axis is the x-axis. So the equation of the directrix will be x is equal to a, or x is equal to 2. And the lattice rectum is always 4a, which is 8. So as I told you, if you remember the previous chart, you can solve any example. Now example 4. Find the coordinates of the focus, axis of the parabola, the equation of the directrix and the length of the lattice rectum for the parabola x square is equal to 6y. Now comparing with our standard form, this is of the form x square is equal to 4ay. So 4a is 6 or a is 3 by 2. So in this case, what will be the coordinates of the focus? 0a. That means 0, 3 by 2. Equation is of the form x square is equal to 4ay. So the axis is the y-axis. Equation of the directrix is y is equal to minus a, which is y is equal to minus 3 by 2. And length of lattice rectum is 4a, which is equal to 6. Example 5. Find the equation of the parabola that satisfies the given conditions. Focus is at 0, minus 3 and directrix is y is equal to 3. As the focus is of the form 0, minus a, what will be the equation of parabola? X square is equal to minus 4ay. So what is a over here? A is equal to 3. So the equation of the parabola will be x square is equal to minus 4ay, means minus 12y. In the second case, the vertex is given and the focus is given. Vertex is at 0, 0 and the focus is 3, 0. Now the focus is of the form a0. So the equation is of the form y square is equal to 4ax. A is 3. So the equation of the parabola is y square is equal to 12x. Please remember the chart. The sums will follow. Next example. Find the equation of the parabola that satisfies the given conditions. Vertex is at origin passing through 5, 2 and symmetric with respect to the y-axis. Now since the parabola is symmetric about the y-axis, what are the possible forms? X square is equal to 4ay or x square is equal to minus 4ay. But it passes through the point 5, 2, which is in the first quadrant. So obviously the equation is of the form x square is equal to 4ay. Now 5, 2 lies on the parabola. So in the equation of parabola, we put x is equal to 5 and y is equal to 2. So we get the value of a as 25 by 8. Hence the equation of the parabola is x square is equal to 4ay. On simplification, x square is equal to 25 by 2y, or 2x square is equal to 25y. Next conic is the ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. That means now you can see in the diagram that for an ellipse there are two fixed points, say f1 and f2, and for all the points the distances, the sum of the distances from that fixed points are same. That means p1 f1 plus p1 f2 will be same as p2 f1 plus p2 f2, and that will be again same as p3 f1 plus p3 f2. These two fixed points are called the foci. The midpoint of the line segment joining the foci is called the center of the ellipse. The line segment through the foci of the ellipse is called the major axis, and the line segment through the center and perpendicular to the major axis is called the minor axis. Now from this diagram, the concept of ellipse will be clear. You can see that the axis on which both the foci are lying is called the major axis, and the other axis which is perpendicular to the major axis is called the minor axis. Also note that the constant, which is the sum of the distances of a point on the ellipse from two fixed points, is always greater than the distance between the two fixed points. Now some notations. We denote the length of the major axis by 2a, the length of the minor axis by 2b, and the distance between the two foci f1 and f2 by 2c. You can see that from the diagram. Now, since the length of the major axis is 2a, half of that is called the semi-major axis. So the length of the semi-major axis is a and the length of semi-minor axis is b. What is the relationship between a, b and c? A square is equal to b square plus c square, or c is equal to root of a square minus b square. Remember this. We define another term. The eccentricity of an ellipse is the ratio of the distances from the center of the ellipse to one of the foci and to one of the vertices of the ellipse. That means, in short, eccentricity E is equal to C upon A. Correct? Now, E is equal to C upon A, so we can say C is equal to A into E. So since the focus is at a distance C from the center and C is equal to AE, in terms of eccentricity, we can say that the focus is at the distance of AE from the center. The standard equations of an ellipse. The equation of an ellipse with center as the origin. We assume over here that the center is the origin and the major axis along the x-axis is given by x square upon a square plus y square upon b square is equal to 1. You can see the diagram. Similarly, the equation of an ellipse with center as origin, major axis as the y-axis is given by x square upon b square plus y square upon a square is equal to 1. So these are the standard equation of the ellipses. Some points to remember. Ellipse is symmetric with respect to both the coordinate axes. Since if xy is a point on the ellipse, then obviously minus xy, x minus y and minus x minus y, all these will also be points on the ellipse. The foci always lie on the major axis. The major axis can be determined by finding the intercepts on the axis of symmetry. That means the major axis is along the x-axis if the coefficient of x square has larger denominator. Remember this. Major axis is along the x-axis if the coefficient of x square has larger denominator, and it is along the y-axis if the coefficient of y square has larger denominator. For example, if the equation of ellipse is x square upon 25 plus y square upon 9, 25 is greater than 9, so the major axis is the x-axis. If a point moves in a plane in such a way that the sum of its distance from two fixed points is constant, then the path is an ellipse, we know this, and this constant value is equal to the length of the major axis of the ellipse. That means for any point P on the ellipse, the sum of the distances from the two foci will be 2a. Remember this, for any point P on the ellipse, the sum of the distances from the two foci will always be equal to 2a. Now we define the latus rectum of an ellipse. Latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci and whose endpoints lie on the ellipse. You can see from the diagram, latus rectum is a line segment which is perpendicular to the major axis and it passes through any of the foci and whose endpoints lie on the ellipse. What will be the length of the latus rectum? It will be 2b square by a. So in the diagram given over here, CD and AB are the latus rectum and the length of the latus rectum will be equal to 2b square by a. Now like we had for parabola, this is a very important chart for ellipse. If you remember this chart, you can solve any example which is based on ellipse. So you have again over here two type of ellipses. First one, if the major axis is the x-axis, and second one, major axis is the y-axis. Correct? So in the first case, when the equation is x square upon a square plus y square upon b square is equal to 1, coordinates of foci are plus or minus c and 0, and coordinates of the vertices are plus or minus a 0, length of major axis 2a, equation of major axis. What will be major axis in this case? It will be y equal to 0. Equation of minor axis, x is equal to 0, length of minor axis 2b, length of latus rectum always 2b square by a, equation of latus rectum, x is equal to plus or minus c and eccentricity is c upon a. Similarly, if the equation is of the form x square upon b square plus y square upon a square is equal to 1, then the foci will be 0 plus or minus c, vertices will be 0 plus or minus a, length of the major axis 2a, equation of the major axis will be x is equal to 0, because the major here the major axis is the y axis, so the equation of the major axis will be equal to x equal to 0. Length of minor axis 2b, equation of minor axis y equal to 0, length of latus rectum again 2b square by a, equation of latus rectum y is equal to plus or minus c, and eccentricity c upon a. Please remember this chart. Example 7. Find the coordinates of the foci, the vertices, the length of the major axis, the minor axis, eccentricity and length of latus rectum for the given ellipse. First case is x square upon 25 plus y square upon 100. Now since 100 is greater than 25, we have just now seen the one which has denominator bigger will be the major axis. So here the major axis is along the y-axis, so the minor axis is x-axis. So what is the equation? X square upon b square plus y square upon a square is equal to 1. So b is 5 over here, a is 10. What is c? c is root of a square minus b square. So over here c is equal to 5 root 3. So from the chart we have just now seen the coordinates of the foci are 0 plus or minus c, that means 0 5 root 3 and 0 minus 5 root 3. Coordinates of vertices are 0 plus or minus a, so 0 10 and 0 minus 10. Length of major axis 2a which is 20, minor axis 2b which is 10. Eccentricity is c upon a or root 3 by 2, and length of latus rectum is 2b square by a which is equal to 5. Second example, 4x square plus 9y square is equal to 36. Since we want the standard form, the right hand side should be equal to 1. So we divide the whole equation by 36. So it is x square by 9 plus y square by 4 equal to 1. So since 9 greater than 4, we know x-axis is the major axis and so minor axis is the y-axis. Comparing with the standard form x square upon a square plus y square upon b square equal to 1, a equal to 3, b equal to 2, c will be equal to root 5. So again, as I told you from the chart, the coordinates of the foci will be plus or minus c 0, that means root 5 0 or minus root 5 0. Vertices a 0 or minus a 0, so 3 0 or minus 3 0. Length of major axis 2a which is 6, length of minor axis 2b which is 4, eccentricity c by a which is root 5 by 3, and length of lateral rectum is equal to 2b square by a, which is 8 by 3. Example 8. Find the equation of the ellipse that satisfies the following conditions. First case, vertices and foci are given. Vertices are plus or minus 6, 0 and foci are plus or minus 4, 0. Now from the coordinates of vertices and foci, it is clear that the vertices are on the x-axis. So what will be the equation of the ellipse? It will be x square upon a square plus y square upon b square equal to 1. So what is a? A is over here. Vertices are given by plus or minus a0. So a is 6 over here, and foci are given by plus or minus c0, means c is 4. We have a, we have c. So from the equation a square is equal to b square plus c square, we can find what is b. So b is root 20. Hence the equation of the ellipse will be x square upon 6 square plus y square upon root 20 square equal to 1, or x square upon 36 plus y square upon 20 equal to 1. In the second case, we are given the ends of the major axis and the ends of the minor axis. I have shown in the diagram to make it clear that first of all, the vertices are on the y-axis. Why? Because the major axis is of the form 0 plus or minus a. That means it is on the y-axis. So the equation of the ellipse will be x square upon b square plus y square upon a square equal to 1. Now ends of major axis are 0 plus or minus a. So what is a? A is root 5. And the minor axis ends are plus or minus 1, 0. So it is of the form plus or minus b, 0. You can see from the diagram. So what is b over here? B is 1. A is root 5, b is 1. So putting in the equation, we get the equation of the ellipse as x square upon 1 plus y square upon 5 equal to 1. Example 9. Find the equation of the ellipse for which the major axis is on the x-axis and it passes through the points 4, 3 and 6, 2. Now first thing, it is given major axis is the x-axis. So what will be the equation? X square upon a square plus y square upon b square equal to 1. Ellipse passes through these 2 points 4, 3 and 6, 2. So in our equation, put x is equal to 4, y equal to 3 and x is equal to 6, y equal to 2. So we get these two equations. Now these are two simple equations which, like you solve any other pair of equations, you can solve it any way. Easy way is you can multiply 1 by 9 and 2 by 4 and then subtract 2 from 1. So you will be getting the value of b square as 13. Substitute the value of b square as 13 in any of the above equations, 1 or 2. You will get a square equal to 52. So what will be our equation? X square upon 52 plus y square upon 13 equal to 1. Next is the hyperbola. A hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. The term difference means the distance to the farther point minus the distance to the closer point. What does this mean? Over here the hyperbola is drawn. F1 and F2 are 2 points. Now over here P1 F2 minus P1 F1. P1 F2 minus P1 F1, that will be same as P2 F2 minus P2 F1, or if you have another point P3, then for it also P3 F1 minus P3 F2. So all these differences will be same. These two fixed points are called the foci. The midpoint of the line segment joining the foci is called the center. The line through the foci is called the transverse axis, and the line through the center and perpendicular to the transverse axis is called the conjugate axis. So the axis on which both the foci lie is the transverse axis and its perpendicular is the conjugate axis. The points at which the hyperbola intersects the transverse axis are called the vertices of the hyperbola. You can see in the diagram the two vertices of this hyperbola. Again over here we consider the origin as the center, which is O. We denote the distance between the two foci by 2c. You can see you have the two foci F1 and F2 over here. The distance between them is 2c. the distance between the two vertices, again over here it is clear from the diagram, the distance between the two vertices which are on the transverse axis is 2a, and we define the quantity b as b is equal to root of c square minus a square, or c square is equal to a square plus b square. So what will be the length of the conjugate axis? It will be 2b. Again over here eccentricity E is equal to c by a, and obviously remember, since c is always greater than or equal to a, you can see from the diagram, the eccentricity will never be less than 1. The foci are at a distance of AE from the center, because C is equal to AE. So the distance of foci from the center is C. So the foci are at a distance AE from the center. The standard equation of hyperbola, the equation of the hyperbola with origin 0, 0, and the transverse axis is along the x-axis. That means you can see the first diagram. If the transverse axis is along the x-axis, then the equation is x square upon a square minus y square upon b square equal to 1. If the transverse axis is along the y-axis, means the second B case, then what is the equation? It is y square upon a square minus x square upon b square equal to 1. And a special case, if a and b are same, then it is called an equilateral hyperbola. Now remember, hyperbola is also symmetric with respect to both the axes, because xy minus xy, x minus y, minus x minus y are all the points on the hyperbola. Second thing is, you know that foci are always on the transverse axis. How will you determine it? It is the positive term whose denominator gives the transverse axis. Means, suppose if the equation is x square upon 9 minus y square upon 16 equal to 1. So, with the positive term you have 9. So, your transverse axis in this case is x-axis, and obviously its length is 2a. X square upon a square means a is 3 over here, so 2a is 6. But for hyperbola y square upon 25 minus x square upon 16 equal to 1. In this case, the positive term is with y. So the transverse axis is along the y-axis. Again, length is 5 into 2, which is 10. Latus rectum of a hyperbola is a line segment perpendicular to the transverse axis through any of the foci whose endpoints lie on the hyperbola. And again over here, the length of the latus rectum is 2b square by a. Again, a very important chart for hyperbola. Remember this chart and you will be able to solve all the examples. There are two forms of hyperbola, x square upon a square minus y square upon b square equal to 1, and y square upon a square minus x square upon b square equal to 1. In each of the cases, the center is given. Center is obviously, we consider it as the origin. Coordinates of vertices in the first case, since the transverse axis is the x-axis, coordinates of the vertices are plus or minus a0. In the second case, it is 0 plus or minus a when the transverse axis is the y-axis. Coordinates of foci are plus or minus c0, or c is a into e. So you can also write it as plus or minus ae0. In the other case, it is 0 plus or minus ae or 0 plus or minus c. Length of transverse axis 2a, length of conjugate axis 2b. Equation of directrix is plus or x is equal to plus or minus a by e in the first case, and y is equal to plus or minus a by e in the second case. Eccentricity, again here it is given by c by a. But what is c? C is root of a square plus b square. So you can also have it as root of a square plus b square upon a square, and in the second case again e is equal to root of a square plus b square upon a square. Length of latus rectum 2b square by a. Equation of transverse axis, in the first case it is y equal to 0 because the transverse axis is the x-axis, and in the second case equation is x equal to 0. So equation of the conjugate axis in the first case is x equal to 0, and in the second case y equal to 0. Please remember this chart. Example 10. Find the coordinates of the foci, the vertices, the eccentricity and length of latus rectum for the given hyperbola. X square upon 16 minus y square upon 9 equal to 1. The positive term is with x, so the transverse axis is the x-axis. So we compare with the equation x square upon a square minus y square upon b square equal to 1. We get a equal to 4, b equal to 3. Again c square is equal to a square plus b square. So c is equal to 5. So what are vertices? Plus or minus a 0. So plus or minus 4 0. Eccentricity c by a, which is 5 by 4. Foci are at plus or minus c 0. So plus or minus 5 0. Length of lattice rectum 2b square by a, which is equal to 9 by 2. So once you remember the equations, it is very easy to solve the examples. Second example, 9y square minus 4x square equal to 36. Now to bring it to the standard form, we want the right hand side equal to 1. So we divide by 36. So the equation is y square by 4 minus x square by 9 equal to 1. Since the positive is with the y-axis, so the axis of the hyperbola is the y-axis. Equation is y square upon a square minus x square upon b square equal to 1. So a is 2, b is 3. Again we can get c, which is equal to root 13. So vertices 0 plus or minus a, that means 0 plus or minus 2. Eccentricity c by a, root 13 by 2. Foci will be at 0 plus or minus c. So 0 plus or minus root 13. And length of lattice rectum 2b square by a, which is equal to 9. Now in the next example, you are given the vertices and foci. You have to find the equation of the hyperbola. The vertices are of the form plus or minus 2 0, means they are on the x-axis. So the equation will be of the form x square upon a square minus y square upon b square equal to 1. You know vertices are plus or minus a 0. So what is a? A is 2. Foci are of the form plus or minus c 0, means c is 3. So again from a square plus b square equal to c square, we can find b equal to root 5. B square is 5 or b equal to root 5. Equation of the hyperbola is x square upon 4 minus y square upon 5 equal to 1. Second case, foci plus or minus 4 0 and length of lattice rectum 12 is given. Now foci are of the form plus or minus 4 0, means on the x-axis. So the equation of the hyperbola is x square upon a square minus y square upon b square equal to 1. We know that coordinates of foci are plus or minus c 0 in this case. So c equal to 4. Length of lattice rectum is 2b square by a, which is given to us as 12. So putting the value, now 2b square by a equal to 12. So 12a is equal to 2b square or b square is equal to 6a. Now you have the equation a square plus b square is equal to c square. In that put b square equal to 6a. So on simplification you will get a quadratic equation whose solution is a equal to minus 8 or a equal to 2. But we know a is always non-negative. So possible value is a equal to 2. When a equal to 2, b square is 6a. So b square is equal to 12. Hence the equation of the hyperbola is x square upon 4 minus y square upon 12 equal to 1. Now in the third case, foci 0 plus or minus 13 is given and the conjugate axis length is 24. Now foci are of the form 0 plus or minus 13. So it is on the y-axis. So equation of the hyperbola is of the form y square upon a square minus x square upon b square equal to 1. You know that foci are 0 plus or minus c in this case. So c is 13. We know that the length of conjugate axis in this case is 2b. Conjugate axis length is 2b. 2b is equal to 24. So b equal to 12. A square plus b square is equal to c square. Putting the value of b and c, we get the value of a square as 25. So the equation of the hyperbola is y square upon 25 minus x square upon 144 equal to 1. Now some different types of examples. An arch is in the form of a parabola with its axis vertical. The arch is 10 meter high and 5 meter wide at the base. How wide is it? 2 meter from the vertex of the parabola. We know that we have considered in all the cases vertex as the origin. So the parabola is along the positive y-axis. So what will be the equation? X square is equal to 4ay. Now x square is equal to 4ay. It is also given that it is 10 meter high. Means what is y? Y is 10 and it is 5 meter at the base. Total 5 meter at the base. That means what will be the value of x? X will be 5 by 2. So from this we can get that the parabola passes through the point 5 by 2, 10. We put this in the equation x square is equal to 4ay. So we get a as 5/32. Now what will be our equation? X square is equal to 4 into 5/32y means 5/8y. We want to find x when y is 2. It is given how wide it is when it is 2 meter from the vertex. Means when y is 2, what is x? X square is equal to 5/8y. In that you put y equal to 2. You get x is equal to root 5/2. But x is root 5/2. But the total width will be from both the sides. So the total width will be 2 into root 5/2, which is root 5. Hence when the arc is 2 meter from the vertex of the parabola, its width is approximately root 5 or 2.23 meters. Next important example, an arch is in the form of a semi-ellipse, not the full ellipse, half of it, so semi-ellipse. It is 8 meter wide and 2 meter high at the center. Find the height of the arch at a point 1.5 meter from one of the ends. Now the length of the major axis over here, we can see the length of the major axis, which is x-axis, is 8 meter. It is given. So the length of the semi-minor axis is 2 meter. This is also given to us. From the diagram it is clear that the length of the major axis is 8 meter and the length of the semi-minor axis, means half of it, is 2 meter. Equation will be x square upon a square plus y square upon b square is equal to 1. So x square upon 4 square plus y square upon 2 square, which is equal to 1. This is the equation, remember, of the semi-ellipse. Because for the semi-ellipse, the length of the major axis will be 8/2, which is 4, and length of semi-minor axis is 2. So the equation is x square upon 16 plus y square upon 4 equal to 1. Let A be a point on the x-axis such that AB is equal to 1.5 meters. So what we want to find? We want to find that height, which is AC in this case, at a point 1.5 meter from one of the ends. Draw a perpendicular AC so that OA, what is OA? O, distance of A from the origin O. So OA will be 4 minus 1.5 meter, which is 2.5 meter. The coordinates of C, let the coordinates of C be 2.5 and y. X coordinate will be 2.5 because the distance between O and A is 2.5. So the x coordinate of C will be 2.5. We want to find AC, means we want to find the y coordinate. Substituting the value of this point C in our equation of semi-ellipse which we have, we get 2.5 square upon 16 plus y square by 4 equal to 1. So what do we get? Y square. Y square we get as 2.4375. So y is square root of 2.4375, which is 1.56 meter approximately. Remember, if you are not allowed the calculators, you can find the square root by the method which we have learned in the earlier classes. Hence the height of the arc at a point 1.5 meter from one of the ends is 1.56 meter. Example 14. A man running a race course notes that the sum of the distances from two flag posts from him is always 10 meter and the distance between the flag posts is 8 meter. Find the equation of the posts traced by the man. Now see, remember, since it is given that the sum of the distances from two flag posts is always 10, we know that it is an ellipse. Correct? Suppose F1 and F2 are the two flag posts, means they are the two focus. And PXY is the position of man at any point. So from the diagram you can see PF1 plus PF2. This always remains same, which is equal to 10. Also distance between F1 and F2 is 8. P is any point on the ellipse. We know that when P is any point on the ellipse, the sum of the distances from the two foci will always be 2a. Remember, we have written this in our set of formulas. Remember this, sum of the distance from the two foci will always be equal to 2a. So 2a is equal to 10 is given over here. So what is a? A is 5. Distance between the foci is 2c. So c is 4. So we have got a equal to 5, c equal to 4. From this we can find b because a square is equal to b square plus c square. So we get b equal to 3. So when we put it in our standard form, x square upon a square plus y square upon b square equal to 1, we get the equation of the part traced by the man, which is x square upon 25 plus y square upon 9 equal to 1. We are solving different kinds of examples. Example 15. An equilateral triangle is inscribed in the parabola y square is equal to 4ax, where one vertex is at the vertex of the parabola. Find the length of the side of the triangle. If you see the diagram, you know that we have taken the origin as the vertex. So O is the vertex, which is the origin. Now suppose OAB is the equilateral triangle, which is inscribed in our parabola y square is equal to 4ax. Let AB intersect the x-axis at the point C and let OC equal to K. We have defined the distance of the point C from the origin O as K. Correct? So now coordinates of A will be, x coordinate will be K and y coordinate is say y. Similarly, coordinates of B will be, x coordinate will be definitely K, and what will be y? Y coordinate will be minus y. So these two points A and B lie on our parabola y square is equal to 4ax. So what is the equation? Equation is y equal to plus or minus 2 root ak. Why? Because your x is k. So equation is y is equal to plus or minus 2 root ak. So coordinates of A are k, 2 root ak, k minus 2 root ak. Now from the diagram it is clear AB is CA plus CB. So what is CA? Distance of C from A, and what is CB? Distance of C from B. And from this it is clear that the distance means the y coordinate, which is 2 root ak. So AB is 2 root ak plus 2 root ak, which is 4 root ak. Now we have found AB is equal to 4 root ak. OAB is an equilateral triangle. All the three sides will be equal. So OA square and AB square will be equal. OA means distance between O and A. O is the origin 0, 0. A has coordinates k, 2 root ak. So OA square by the distance formula will be k square plus 2 root ak whole square, which is k square plus 4ak. So now OA square is k square plus 4ak, and that is same as AB square. AB square is the square of 4 root ak, means 16 ak. So k square is equal to 12 ak, or solving it we get k equal to 12a. Now we have got the value of k as 12a. This value you can either put in AB or you can also put in OA. You will be getting the length of the side. AB is 4 root ak. In that you put k equal to 12a. You get it as 8 root 3a. All the three sides are equal. Hence the side of the equilateral triangle inscribed in the parabola will be 8 root 3a. Students, this is a one-shot video on conics. We have discussed ellipse, circle, parabola and hyperbola in detail. Please do like and share the video and subscribe to the channel.